All right, so GVWD open. The agenda, you'll notice, was amended at the last minute because there was inadvertently a couple pages missing in the minutes, not anything we're actually dealing with, so that was that update. So with that, the agenda's been moved and seconded. Any questions or comments? Seeing none, all those in favor, opposed, carried. Minutes from November 25th, moved and seconded. Any errors or omissions? Seeing none, all those in favor, opposed, carried. We have a consent agenda. I'm actually going to pull 2.3 just because our staff's going to do a very quick presentation because I think it's something very innovative and creative that we're doing. And I have received feedback from many people that when we have some of these, just to take a little bit of a timeout so that we can get a little bit educated on what's going on there. But so I'll pull 2.3. Would anybody else like to remove anything else out of the consent agenda? All right, the remainder of the consent agenda has been moved and seconded. Last chance. All those in favor? Opposed? Carried. All right, 2.3. We'll set up for a quick presentation there. Where's Lori? Oh, there's Lori. Hi, Lori. All right, floor is over to you.
Great, thank you. Good morning, everyone. Thank you, Mr. Chair. So I'm here this morning to give some information on the results of Metro Vancouver's industrial trial using drinking water treatment residuals at the Lafarge cement plant and recommend that the GVWD and the board enter into a multi-year agreement with Lafarge for use of the residuals as a substitute for shale in their cement manufacturing process. So what are drinking water treatment residuals? So they are the thickened dewatered solids that are removed during the filtration process at our Seymour Capilano filtration plant. And I have a sample here that I'm going to pass around in a second so you can see them for yourselves. Everyone likes show and tell. They consist of materials from the source water and treatment chemicals that are used in the filtration process. And they're a semi-solid product with the consistency of a moist clay, and the solids content is about 15 to 20%, and the rest is water. So I'll just pass this around. So what you're seeing in the slides here are, on the left-hand side is the dewatering process. So those are called belt filter presses, and the wet thickened material that's removed from the filtration process is poured onto the belt filter press at the beginning, and then the water drains through this belt. It's a porous belt, and then another belt comes on top of it. The material gets squeezed between the two belts, and then they're compressed through a series of rollers, and the water is squeezed out. Think of an old wringer washer if you've seen one of those, and it's the same principle. And so the material that's coming out has no free water associated with it. It's not dripping, but again, there is still quite a bit of water inside there, which is why it's kind of a damp material. And those are what we're referring to as drinking water treatment residuals. So those residuals leave that belt filter press and they travel by conveyors to the handling area in our facility, and then they're loaded into trailers for removal. So in the photo on the left, you can see a close-up of the material as it's dropping out of a chute into the back of a truck, and then the one on the right is just the trailer from a little bit further back. So since the Seymour Capilano filtration plant was commissioned, we've explored potential beneficial uses for the drinking water treatment residuals to divert them from landfill. And one beneficial use option that was identified for the drinking water treatment residuals is in cement production as a substitute for shale, which is one of the raw materials used in the process. So last April, I presented to the Utilities Committee a recommendation to undertake an industrial trial to determine the viability of using this material in the cement manufacturing process. Because, as you can imagine, this material has very different properties than shale. And so they had to figure out how they could use it, what are the operational challenges, how would they be able to use it in their process. So we recommended that trial as a substitute for the red shale that's used in the manufacturing process. So right now, Lafarge's shale comes from the Abbotsford area, and the use of the drinking water treatment residuals as a substitute for a portion of this feedstock would reduce the harmful emissions that come from harmful diesel particulate emissions that come from extracting and transporting the raw materials, and would also divert our drinking water treatment residuals from disposal. It would also result in a reduction in the cost of disposal to the water district. And so last April, the board supported undertaking this trial. And so in June, we started working on this trial. So for the purposes of this trial, Lafarge set up a temporary on-site area for delivery and storage of the drinking water treatment residuals. So that's what you see in the left picture there. It's lock blocks in order to contain the residuals. And then on the right, you can just see a little bit closer up. And you can see on the left there, the truck is delivering a load of residuals. And so one of the considerations as well is around delivery and making sure that there's enough area for turning radius and clearance, because these are fairly large trucks that we're using. So then on the left picture, what happens is the residuals are mixed with sand, and the mixture is then fed into the plant with a clamshell in the appropriate portions of the different raw materials needed. So you have this clamshell that comes down, picks up the material, goes over, drops it onto the belt, and there's the other materials that you can see beside the mix on the left-hand side there. So those are also picked up in the proper proportions for what the cement process needs. And then this material goes up the belt. It goes into what they call the raw mill, and at that point it's ground into a very fine powder, all of the mixture together, and homogenized. So then from that point, it's blown up. On the left-hand side, you can see the arrow going straight up. There's a pneumatic blower that blows that fine ground material up into the top of this building. This is called the PreCalcinator, and it travels down through that building on the right-hand side there, the blue and white building, and it goes through a drying process and then into the kiln. And the kiln is that long cylinder, horizontal cylinder at the bottom. And the temperatures in the kiln are about 3,500 degrees. And so essentially all of that rock is melted, fused into what's called clinker. And that clinker is the ground material that is essentially Portland cement. So over the course of the trial, Lafarge was able to get a feeling for the material and how they could work it in order to use it in their process. So over the course of the trial, we were able to send 6,000 tons of our drinking water treatment residuals. And just for context, we produced in the order of about 10,000 tons of drinking water treatment residuals a year. In the course of sending that 6,000 tons, we displaced about 1,200 tons of virgin materials, so that red shale that we were referring to. And by doing this, we were able to save $240,000 in tipping fees in sending that material to the landfill. So over the course of the trial, we were able to work with Lafarge, and they were able to identify a number of these operational challenges. And so that temporary storage area was just for the purposes of this trial. So they were able to get a feel for what kind of a storage capacity they would need and where they could potentially put that. As I mentioned, these trucks are very large, and you can see a picture of the truck there again, which is delivering the material. And so it needed to be an area that they could deliver the material and have enough space to be turning around, back up safely, have enough overhead clearance. And then what they found was by blending that material with that drier sand, they were able to get a fairly consistent product that they were able to feed continuously into their process. So similar to other regional industrial operations, Lafarge requires an air quality permit, and that establishes emission concentration limits that achieve ground level concentrations that are protective of human health and the environment. So within that permit, there were requirements that around any authorized fuels and raw materials that they're using, they have to undergo a trial, or they go through a stack test when that new raw material or fuel is used. So in September 2015, March, and December 2016, Lafarge tested drinking water treatment residuals during their quarterly stack tests, and those were at representative rates for what they would be using in the future operations. And the test showed that all the levels for the permitted discharges were well below their air quality permit. And so as such, the drinking water treatment residuals are acceptable for use as an alternate material as per our air quality regulations. So based on the success of the trial, we're putting forward a recommendation that the board authorize that the GVWD enter into an agreement with Lafarge for the use of our drinking water treatment residuals as a raw material at the Lafarge Richmond Cement Plant. And so, as I mentioned, we are projecting that we'll be generating about in the order of 10,000, but it could range from about 8,500 to 11,000 tons of residuals a year. And again, thinking about if we were to divert all of that from landfill to Lafarge, assuming 10,000 tons a year, it would replace 2,100 tons of shale and the associated emissions that come with that. It would save GVWD over $400,000 a year in the tipping fees, and it would divert that material from landfill. So if the board authorizes entering into an agreement with Lafarge, our next step would be to work to issue a notice of intent to contract. And what that does is it just provides the opportunity for any other parties that are capable of doing the equivalent arrangement for the same cost to come forward. We're not aware of any others that are capable of accepting the drinking water treatment residuals in the dewatered form, but this process would confirm that. So assuming that there are no other parties that are able to do this, we would then enter into a 3-year agreement with Lafarge with the option of a 2-year extension. That's what we're proposing. So Lafarge needs us to be able to commit a minimum volume of 6,500 tons a year and a 3-year minimum in order to justify the investment that they're going to need to make, because they're going to have to invest in a storage facility, a larger permanent storage facility, and they will have ongoing operational costs, so they need that commitment from us to make that investment. And by having that 6,500 ton a year minimum, that would also give us a flexibility to explore other alternatives for the use of residuals at the same time, but we have the option to send 100% of it to Lafarge. So I'm happy to take any questions.
Excellent. Thanks, Laurie. I think that was worthwhile to learn something pretty cool and innovative that our staff in working with Lafarge is doing. I think worth the presentation. So we have the motion. Oh, would somebody like to? Oh, you have a question, Director Harris? Or let me just get the motion on the floor. Someone like to move this? Moved and seconded. Director Harris?
Yeah, thanks. This is fascinating and a great idea. I just had 2 questions. One was, are there examples of this happening elsewhere? Are we the first, either that we know of? And the second is there a prospect, or has consideration been given to the possibility of revenue from our residual materials as opposed to giving them away for nothing? And I just wondered if that's I don't suggest we do it now, but I'm just wondering if that's even a possibility.
Sure.
Thank you.
Laurie?
Yeah, so with response to the first question, are we the first? I know that there are cement plants that are using biosolids as a fuel source in some parts of the States. I am not aware of any of them that are taking drinking water treatment residuals at this point. And so as far as I know, we would be the first, but we can find out. And in terms of possibility of revenue, that is certainly something that hopefully, if we can continue on with this, create enough of a demand for this product, and we are exploring other uses for this product. So if we can create enough of a demand for the product down the line, hopefully we will get to a point where we're able to actually create a revenue source for the material. So I think one step at a time, once we're able to prove the success of this, and find out what our other uses are, then yeah, that is certainly the goal.
Thank you. And so at the moment, Lafarge is paying us for the materials, or we're paying them to take them?
Laurie?
Yeah, so we will be paying them to take them at this point, and that is because of the investment in the capital infrastructure and their operating costs to mix that material. And the intention is the 3-year contract would be renegotiated after the 3-year term, and looking at what if we need to renegotiate that cost at that time.
Thank you. There's a good news story to tell.
Absolutely. Thank you. Director Stevenson.
Thank you, Chair. Actually, just to the last point, the committee thought that it would be really an excellent idea if somehow we got this news out. I mean, it's really a good news story, and if communication somehow got out to the public, just
Agree.
what an innovative thing it is.
Yeah. Good point. Heather's on it. Director Stewart.
Thank you. So the question I look at is obviously where there's some savings on the disposal side, but it's not a net savings. It's this new process would cost us cost Metro Vancouver significantly. Would it, or am my math wrong?
Sorry, I didn't quite hear the end of it.
You referred to some savings on the disposal side for the 10,000 tons a year. That's not net savings though, that's
That is net. It is net savings, yeah. So the $400,000 per year would be net. The cost for taking the material to Lafarge is approximately half of what we would be paying for taking it to disposal.
There you go. Okay, because I read the report over and over again, I couldn't get that. So there you go. Thank you.
Thanks for that clarification. Alternate Director McKay Dunn.
Thank you, Mr. Chair. Just a quick question for information. This is my first meeting. What is the composition of the residual?
So essentially, it's the material that's coming out of the reservoirs. So it's any sort of silts or clays that are being filtered out, and then any of the coagulants or polymers that are used in the water filtration process, because those materials are quite fine, and so you have to add coagulant in order to make them bind together to be able to remove them in the filtration process. So that's what's in it, and then a lot of water.
Then these materials are considered to be deleterious then?
No, they would not be considered deleterious.
Thank you. Thank you.
Thank you for your questions. Thanks, Laurie. Appreciate all that information.
Thank you.
All right, we'll call the question. All those in favor? Opposed? The motion carries. Resolution to close under 91K. Moved and seconded. All those in favor? Opposed? Carried. Motion to adjourn. Moved and seconded. All those in favor? Opposed? Carried.